Hello students, last session we have seen text search algorithms in hardware part, like we can go for the distributed system, parallel processing or whatever it may be. Now we are completely going with the software text search algorithms. So what are the different software text search algorithms available, like you can change in your software technologies not related to your hardware. So first one is brute force approach. Brute force, generally you know that whatever the document is available, I have to check everything. That is called as brute force. Next one is Knuth-Morris pattern. Next one is Boyer-Murray pattern or shifter algorithm you call, and Rabin-Karp. So we'll see all these algorithms in detail coming over the patterns. So what you are doing, among of all the algorithms what I have mentioned, so the most Boyer-Murray has been fastest one because it requires only O of n plus 1. Okay, so n is your terms and what are the basic searches you are doing, and this Pratt-Moore is KPM algorithm, and this both Boyer-Murray algorithm also used O of n. So we will consider these are best, and brute force approach is the simplest approach, but the complexity will be always high, right? And the idea is to try to match the string against the input text. So we'll see. So for example, if I have the complete text A, B, C, D, E. So if I get B, C, D, I want to check the pattern where I'm going to matching. So this is a basic concept in this algorithms, right? So whenever mismatch, any of the mismatch is detected in the comparison process, we have to shift the input text one position and start the comparison process over. So you will understand while we are doing the algorithm, so no issues, don't worry. And the expected number of comparisons of the text string of the characters will be given by the formula this one. So NC equal to C by C minus 1. You please just remember this formula, 1 minus 1 by Cm, n minus m plus 1 of O of 1, where NC is the expected number of comparisons. So total how many comparisons I am going to do with the existing text to the string. Okay, so this can be calculated using this particular equation. So this is a pattern. For example, we are starting with the KPM algorithm. So here I have a pattern A, B, C, D. So if you see here A, B, C, D, A, B, C. So I am taking only the order of this particular 1, 2, 3, 4, 5, 6 and 7, right? So what we are going to do now? So now we have to find out the number of substrings you can do over here. So from the given pattern, I can give prefix. What are the prefix? AB, A, AB, ABC, ABCD, etc. Coming to the suffix, I can create C, BC, ABC and DABC. So if you see the example, so these are the prefix and suffix, okay? So I can create, one second, yeah. I can create A from here, prefix I am talking. First I can create A, then next I can create AB, then I can create ABC, then I can create ABCD, ABCD, ABCDA, like that I can create. Coming to the second pattern from suffix C, CB, yes, C and CB you will get, then ABC, I am starting from C, right? Then you will get DABC. When you do this, what happens? You will get a common pattern in both. Prefix and suffix, when I create, I got a common pattern, right? What is a common pattern over these two? ABC, ABC. So here ABC and ABC are the common patterns. So this is a thing which is repeated twice in the given pattern. So this is your example. Once you see the example, then you will understand. So what we are doing, this is my pattern A, B, C, D, A, B, E, A, B, F. So how I have written pattern 1 here is A is occurred only once, B is occurred only once, C is occurred only once. Once means all times I'll put 0. When again the A is repeated, I'll mention 1. B is repeated again, so 2. If E is already not there, so it is 0. A is again repeated, so I'm mentioning here. B repeated 2. So A implies the first term which is repeated, B implies the second term which is repeated. If F is not there, if suppose E is repeated here, that it will be the third term. So this is one pattern. Second pattern, similarly A, B, C, D, E, till now no repetition. 1 is the first pattern repeated, B is the second pattern repeated, and if you see F, it is not repeated. Again, A is the first pattern repeated, B is the second pattern repeated, C is the third pattern repeated. So like this, you have to create the patterns. So when you create all these patterns, you have to check where it is going to repeat the values. So this is one example for the algorithm. Now I have a string here, A, B, C. So whatever the string I am having, my pattern is only A, B, A, B, D. Remember, these A, B, C, D all are not in the sequence. So don't think that it is A to Z, 26 alphabets, no. So it is a pattern. Now I am checking this is my string, and this is my pattern. Now I have to check where it is going to occur. Now what we have done, so this is your 15, I'll start from A. So when I take A, so it is pattern is, no, it is not repeated 0, B not repeated, A is repeated 1, B is repeated, yes, B already 0 is there, so it is a second pattern repeated, and D is 0. See, this is the value you are going to calculate. So here, just the thing is, here A is repeated, so you have to keep the index as 1 below it. B is repeated, so keep the index below 2, and rest all 0. Then what we are going to, this is algorithm, so you have to learn this algorithm. So first you have to initialize the string as I, pattern index as j. So then start j from adding 0 index. So compare the string of I plus j plus 1. So you are taking string I, this is your string, and your pattern here, and you are comparing j plus 1. So first I will check with this pattern. Then if A and A both are matching, so move I to the j and to the next position. Move both and I. So if it is both are matching, this will become I plus 1 and this will become j plus 2. Okay. So again next position. Now compare string of I with the pattern of j, and B matching, so move both to the next position. So this is the algorithm where you are going to compare each and every pattern and a value, given value. So for example, when I equal to 5, j equal to 4, string I of equal to C and j pattern j plus equal to 2. So there is no matching because I is C and j plus 1 is D. So then you won't say anything. So what you have to do? You have to position to the pattern 2. So just you are making j equal to this one. Similarly, when you have the pattern I equal to C, j plus 1 equal to A, then also you won't change anything. So like this, you have to repeat this particular pattern until you find the complete match with the pattern with the string. So what we are doing, I am taking I, here I am taking j plus 1. If both are match, move this I to I plus 1 or j to j plus 2 because already j plus 1. If I and j plus 1 are not matching, only I will move the pattern to I plus 1 and j will not be moved to j plus 1. That is the thing. So better this you have to implement in order to get the patterns. So this is a KPM algorithm. Like this, you can search the complete thing with the help of this process. Thank you.